everyone, I'm Serish and you are learning chemistry with me. In this video, we are going to discuss the past paper of chemistry basically. And here is the full paper. We are discussing the multiple choice questions, the paper one, and it would be divided into different videos. You need to watch the other videos for a complete paper. So let's move to this question. The question number one states, consider the following statements. Number one, the silicon dioxide has a higher melting point than sulfur dioxide, and the second statement is ammonia has a higher boiling point than phosphine. So which statements are correct? Let's focus on their bonding. When we talk about the silicon dioxide, we believe that it's a macromolecule and it has an extensive bonding. Silicon dioxide, while in sulfur dioxide, the bonding, it's a micromolecule, though there is a covalent bonding, but the type of bond or the type of interconnection between different atoms is lesser as compared to dioxide. So number one statement is completely true that there are more bonds, the stronger bonds, which leads to the higher melting point. Let's move to the second point, which says the ammonia has higher boiling point than the phosphine. So we believe that in ammonia, the nitrogen is present. So nitrogen is highly electronegative element. So there are three elements which we consider more electronegative than the others, which are nitrogen, oxygen, and fluorine. So whenever hydrogen is attached to any one of these, the bonding is much stronger as compared to the other elements. So though we believe that nitrogen and phosphorus both are the non-metals, both belong to group number 5, but when we talk about their bonding or the type of bond or the strength of their bond, then we say that nitrogen has a stronger bond because of its high electronegativity. So the statement number 2 is also correct. So our answer would be that both statements are correct. The next question is, how many neutrons are contained in one atom of iron with a mass number of 60? So we know that the um, atomic number or the proton number of iron is 26. So if the mass number is 60, we just need to subtract it in order to get the number of neutrons. So when we subtract it, our answer would be 34. So answer would be C. The next question states, it's about the Boltzmann distribution of molecular energies. Okay, the diagram shows a Boltzmann distribution of molecular energies for a gaseous reaction at two different temperatures and two different activation energies. So let's say the temperature 1 is high and temperature 2 is low. So which combination of temperature and activation energy will give the highest reaction rate? So we believe that with increase in or decrease in increase in temperature and decrease in the activation energy would give the highest rate of reaction. So let's see what we have over here. So this is temperature 1, okay, and this one is this one is the energy that is associated with T2, and this one is the energy that is associated with T1. Okay, let's say which has the highest reaction rate or the proportion of molecules. Okay, so our answer would be D, because the temperature 2, which in which there is good combination of the temperature and the activation energy, which increases the rate of reaction. So the reaction between sulfur dioxide and oxygen has the equation shown, and the equation is, okay, let's see, the equation is 2 sulfur dioxide plus oxygen, it gives 2 sulfur trioxide, and this is related to contact process as well. Okay, 1 mole of sulfur dioxide and 1 mole of oxygen are placed in a closed container to a constant temperature. At this temperature, 0.8 mole of sulfur dioxide are present in equilibrium mixture. Which statement is correct? Okay. So first of all, we should know what is our limiting reactant. So I believe that sulfur dioxide is present in a lesser concentration as required, because the molar ratio is 2:1. It's not 1:1. So the sulfur dioxide would be our limiting reactant. So the amount of sulfur trioxide produced will be depending on the sulfur dioxide one. So there are only zero point 0.8 moles of sulfur trioxide produced. Okay, so the statement statement is correct. Number one, the equilibrium partial of pressure of SO2 is greater than the equilibrium partial pressure of oxygen. Number two, the Kp has the unit of mole per cubic decimeter. We need to calculate it whether the unit is same or not. Then the third one is at the lowest temperature, the equilibrium uh, amount of SO3 is lower than zero point 0.8. Okay, this cannot be correct at all. The molar fraction of SO3 is lesser than zero point 0.8. Of course, when we take the molar ratio, our overall mole fraction would be decreased. So our answer would be D. Number five is red lead is a pigment with a formula of Pb3O4. Every formula unit of red lead is same. Each formula unit contains 3 lead ions and 4 oxide ions. Lead has two different oxidation states in this one. What is the oxidation state? Now, if it's a simple one, we just use a formula that x plus y is equal to 0, and then we place it like this. And if there is any coefficient, we divide it and we get the answer. But here we have two different oxidation states. So let's balance it. So we have 3 lead ions like this, and this. And they are in the combination with 4 oxide ions. So let's talk about their oxidation state. So how many would have which type of state? Okay, so when we generally say this, so we say that it would have um, a combination of two oxidation states. So one cannot be there, so we are just excluding one. Let's talk about two. So both contain 2, just 2 is over there. Let's apply this. Like for example, if one contains 6 and 2, it won't give you the answer. But if the two contain 2 and one contains 4, that would be a suitable explanation of this one. So our formula would be plus 2 and plus 4. Next question is some standard enthalpy of combustion data is given. Okay, we have carbon, hydrogen, and methanol. So using these data, find the enthalpy change of formation of methanol. So what we need to do, we need to calculate it. Let's say that we have okay, heat of formation. We have carbon and we have hydrogen and then we have oxygen. It gives us methanol, right? Which is CH3OH. Let's balance it. So we have one C, then we have 4 hydrogen, and then we have half oxygen. Okay, so this is our general theory of how to explain it. Let's calculate it. So the enthalpy change for carbon would be 394, hydrogen would be 286, and this methanol is 726. So first of all, we calculated for oxygen, the value of oxygen would be different, and then when we put it together, so our final answer would be 240.